This unit, we're digging into ways to analyze data. So, data is going to be data means it's just all the information that you can collect from somebody. So, data is a big part of our lives. A lot of people are collecting data on us every single day, and it's a matter of what can we do with that data to help us solve problems, to help us understand situations. And this unit's designed to give us an introduction to data and kind of what are some things that we can do with it to help describe it. So this video is going to go through 6 A, B, C, and D. It starts out with discussing different types of data. So the first type of data we have is categorical data. Now, categorical data means that the data is grouped into categories. It's not necessarily going to use numbers. It's going to typically use words or things that could group our information together. So some examples of categorical data are going to be type of shoe purchased. So if we're a shoe store and we're trying to analyze who's buying what types of shoes, we might look at what type of people are buying high heels or tennis shoes. Or on average, this store sells mostly tennis shoes, where a different store sells mostly dress shoes. And so we're trying to figure out what kind of shoes to stock. Gender would be a grouping, okay? So typically, like if you're filling out a survey, they might ask for gender on that survey, and that's grouping people into certain categories there. Ethnicity or race. Okay. Those are going to be types of data that are grouping people into like sets. It's not collecting numbers. It's more of a grouping with using words. So this categorical data is typically going to describe different characteristics of the group. So then we also collect data that's numerical, and numerical data is where our main focus is going to be as far as analyzing that data. So a name for numerical data is quantitative. This needs to have a number value. So if we're collecting data by how many, we have a tree farm, and how many apricots does each tree produce? Okay, so that would be a numerical data. We've got numbers involved. If we're looking at baseball players and how far they hit the baseball each time, that's a number, okay, distance. If we're looking at track athletes and how long it takes them to run a certain distance, we're talking about numerical data, okay, a time that it takes to do certain things. Whenever we collect numerical data, sometimes it's discrete and sometimes it's continuous. So for discrete data is where we don't have decimals. We don't have all of these in-between values. So for example, let's write discrete. There's some fine lines sometimes between discrete and continuous, and if an argument was provided, we could maybe consider certain things in either category. So discrete is usually a result of counting. So the tree example I gave you would be an example of discrete data. So a tree, an apricot tree, could produce, it's not going to produce a negative number of apricots. It could produce 1, 2, 3. I don't know anything about apricot trees. I don't know, maybe one of them produces 1,000 apricots in a year. And so we might be looking at what's the average number of apricots that the trees on my farm make. Or we're trying to figure out which trees to get rid of, because we want to get rid of the ones that are producing, we don't want to get rid of all of our trees. We just want to get rid of the 20%, the lowest 20% that are not producing well, and keep the upper 80% or something like that. But your trees, what fits here under discrete is your trees are not going to produce 1.5 apricots. They're not going to produce 3.9 apricots. We're not going to have these in between values. We can just count the number. So we won't have 2.6 apricots on a tree. We're not going to have those decimal values. There's other types of data where we do have decimal values, and these are called continuous. So this is usually a result of measuring. My examples that I mentioned a second ago about running a race or hitting a baseball would be examples of continuous data. So time taken to run a race. How about 100-meter race? So if we all went out and ran 100 meters, that's like a quarter of the way around a track. Let me think. So 1,600 is a full mile, 800 is a half mile, so 400 is the whole track. Yeah. So that would be about a quarter of the distance around a track. So if I don't know how fast people would run that in. So maybe we all went out there and our values might range from 9.8 seconds to 25 seconds, right? But you can run decimal values. So I might run a quarter. I don't know how long that would take me. How long would that take me? So it takes me about 2 minutes to get all the way around the track. But if I sprinted, so I might fall like in the 20 seconds-ish, okay? So maybe I run as hard as I can and I hit 20.2 seconds, okay? We have these decimal values. It's not just whole numbers. We can have decimal values for that. Distances would be continuous. So if we're measuring the distance you hit a baseball, you could hit a baseball 101.23 feet or something like that. You can have those decimal values. All right, the next piece we're going to do is we're going to work through from section B. We're going to work through question 6. I'm going to copy it over here, but if you want to look in the book, so we're looking at page 165. We're going to work through problem 3. In chapter 6B, it starts talking about different ways to display data, and you should have a little bit of experience with some of these ways of displaying data. So we are looking at 6B, question 3. It says, while watching television, Joan recorded the number of commercials in each break and obtained these results. So I'm going to just abbreviate number of commercials in each break. And she gets this data. So 5, 7, 6, 4, 6, 7, 5, 8, 7, 6, 9, 8. First, this data would be considered discrete, because we're not going to watch a half of a commercial during a break. Commercials, you're going to have full numbers of commercials each break. 5, 6, 9, 7. Okay, I hope I wrote that down right. So we're going to have a whole number of commercials. So this is considered discrete, quantitative discrete data. So numerical, but we have whole numbers of commercials. So first thing we're going to do is construct a frequency table. So what is a frequency table? So first off, this data is icky looking. This doesn't tell me much. I just have a whole bunch of numbers, and she just wrote them down, and that's fine. But it's nice to have a good way of displaying this data so we can start to make sense of it. So first way is a frequency table. So this is a frequency table. So a frequency table, what we do is we take note of our data. So first column is our data, which is number of commercials. And we look at all of the possible outcomes we have for number of commercials from our data. So the lowest number of commercials that she recorded was, here's a 4, and I don't see a 3, so 4. There's data for 5, 6, 7, 8, and 9, and that's the highest value it gets to. If you would like, you can include a tally column. This might help you stay organized, but it's not required. So second column, if you would like, you can tally. It might help you keep organized. And so what do I mean by tally? We're going to tally up, we're going to work through our data and tally up how many of each there are. Make sure, I think I got all the data. So 5, so tally. 7, tally. 6, 4, and I'm just going through the data, putting tallies to indicate each value, which might help you keep organized. So that's after the first row. Then we have a 7, a 6, and I'm just keeping going here. Now when you get to a 5 with tallies, remember you tally across. That's after the second row, if you're making sure you're doing this right. Whew, okay, I hope that's right, because this is on video, so can't change it if it isn't. So there's my data. Some things you can start noticing from tallies is that 6 is the most likely number of commercials that's going to happen. 7 would be next, and then it sort of tapers off from there. Rarely do you only watch 4, okay? And 9 is also pretty rare. So in our next column, we're going to write frequency. And we're going to count up our tallies. So 4 happened twice. There were 2 times that we had 4. The frequency of 5 commercials was 5. That happened 5 times. The frequency of 6 commercials was 10. 7 happened 9 times, and 8 happened 5. 9 commercials happened 3 times. So that's our frequency of each outcome. So these are the outcomes that occurred. The frequency that each one happened is in our next column. And our relative frequency is a percent. So down here, total. So how many commercial breaks did she watch? Seems like she was busy watching TV for quite a while. So we would add up our frequency column, which gives us the total number of commercial breaks that she watched through. So let's see, 5, 6, 7, 17, plus 9 is 26, 31 makes 34. In our last column, we're going to put the relative frequency, and a relative frequency compares how many times a certain event happened compared to the total number of events that you watched. So it's like a percent. So 2 times we had an outcome of 4, and so what percent of the time do we expect to watch 4 commercials on a break? And so to do that, we divide the 2 over 34, and we'll write that as a decimal. So 2 divided by 34. Let's double check my 34 real quick so we don't get too far into this problem. Cool. So 2 divided by 34 gives me 0.059 as a relative frequency. This is a decimal. This would represent 5.9% of the time. We take 5 divided by 34 for our next one, and 0.147. We'd expect 14.7% of the time to watch 5 commercials. Okay, 10 divided by 34, this is the most likely outcome to happen, and it happens 29.4% of the time. 9 out of 34, this is the second most likely, 0.265. Let's see, 5 divided by 34 gives me 0.147, and 3 divided by 34 is 0.088. 8. So those are relative frequencies, so they're in relation to how many shows that you watch. Relative. Okay. And that's the frequency table. That's a complete frequency table that displays how often should you expect to watch different commercials on your break. To go from frequency table, we can go down to a column graph. So B would be a column graph, also called a histogram. So in a column graph or a histogram, it's like a bar chart is another name for it. So down here we're going to put number of commercials. And over here we're going to put frequency. So our biggest frequency happened 10 times. And so for our frequency we're going to want to get sure to get to 10. So I'm going to count by 2s. And our biggest number of commercials was 9. So we could include 0, but you don't necessarily have to. You could start with 4. I'll just go. You don't have to start at 0. I have room though. But we have to get to 9. And we're going to make a bar to indicate the frequency for each of these happening. So 0, 1, 2, and 3 don't happen at all, but 4 commercials happened 2 times. This is a way to give a visual representation of our data. So 5 commercials happened 5 times. 6 commercials was 10. 7 commercials was 9. 8 commercials happened 5 times. So 8 is equally likely to 5, and then 9 happened 3 times. Bar charts help us visualize what's going on, so you can kind of see where the peak is. Most of our data where it's clustered, so most of it's clustered around 6 to 7 commercials happens the most. And so that's a histogram, or it might be called a column graph. Mode, I've been talking about it all along, so part C asks for the mode. Mode's the most occurring. Most occurring value, so the mode here, most likely to occur was 6 commercials. So we can pull the mode directly from our frequency table. It's the most frequent. 6 commercials was 10 times. Most frequently occurring item. On part D, it says describe the distribution. Are there any outliers? So an outlier is a value that's separated from the rest of the values. All of our values are clustered together. So there's no outliers. So on D, now this isn't one of our data points, but what would an outlier look like? It'd look like this, okay? So it's separated from the rest of the data. It's probably not going to occur, right? But this would be considered an outlier. Separated from the rest, only occurs once. It could occur maybe twice if there was a ton of data. We don't have a lot of data. So it'd be something that occurs only once. It could be off on the other side as well, like 12 commercials or 13 commercials would be considered an outlier. What percentage of breaks contained at least 6 commercials? Is the last. What So what percentage of breaks contained at least 6 commercials? This is where a relative frequency is handy from up above. At least 6 commercials would include the 6 commercials. So let's look up above. 6 commercials or more, right, would cover the at least piece. So what percentage of breaks contained exactly 6 commercials would be 0.294, would be 29.4%. But for at least, we're looking at all of the numbers above. So I'm going to add those together. So I'm pulling my relative frequencies. There's lots of other ways to do this. You could also add up all of the instances here and then divide that by 34, or you can add up all of your relative frequencies. Either way. So 0.294 plus 0.2. Now these are all rounded, so that could add a little bit of error. So 79.4%. So I'll show you the other way you could get this. So let's say your relative frequency table isn't constructed or it's not handy. We could also add 10 plus 9 plus 5 plus 3. So 27 instances, we had at least 6 commercials. And that gives me my 79.4. I wrote that backwards. So we did get the same answer. I just wrote it backwards. Okay. Percent of the time. So that is our that's how a frequency table, a calling graph works. Now, sometimes our data isn't whole numbered values like it was in that instance. Sometimes we've got decimal values. And so what we need to do with decimal values is group them. So in part C and also in D, they kind of merge together. They're very similar. We're looking at grouping data into classes. So before we had whole numbers, so it was easy to list them all out. 4, 5, 6, 7. That was the number of commercials. It's not so easy to list whenever you have decimal values. So let me write down some data to describe this. So decimal values. Example. Weekly supermarket bills for families. So how much money are people spending at the supermarket? Well, we could spend decimal amounts here. So, for instance, somebody could spend, I'm going to make a whole list of data, 72.05. Somebody might spend $73.16. Another family spends $75.90. Somebody gets a bill, it's exactly $80. You want to write these numbers down. We're going to have an announcement.
Teacher's presence interruption.
Okay, so we've got that, 84.40, 85, 91, just all of these are different supermarket bills. I'm writing my data in order. The data might not be given in order. Sometimes it might be given out of order. Okay, so just take note that could happen. Ooh, data's fun. A lot of writing. So there's some supermarket bills, okay, for a week of buying food. So might want to pause and write all those down. We need to be able to have a good way of representing this data using a frequency table and also a histogram. So in order to do that, we're going to have to group it. So to group it, we need to pick categories that make sense. So my smallest number is 72, my biggest number is 145. So grouping by tens makes sense for this data. So we could take note of all the bills that fall in the $70 range, then the $80 range, the $90 range, the 100, 110s, 120s, 130s, 140s. So that's not going to be too many to think about. We do this because look at the only repeat is this bill right here. I don't see any other repeats. that's the only repeat. So if I'd made a frequency table, but I only had one value that repeated twice, it doesn't tell me very much for my data. So I'm going to group this data. First, we are analyzing 30 total outcomes here. So that might help us here in a minute. But let's go ahead and make our frequency table. So supermarket bill. That's the first column in our frequency table. And we said we're going to group it. So I'm going to write this two different ways. Either way would be correct. So we could say, well, in this case, never mind. We're only going to be able to write it one way. So we're going to say that a bill could be between 70. I'm going to use X and 80. Now, we're trying to group it in the 70s and 80s. So 70 falls within the 70s, so I want to include it. I don't want to include 80 in this category. 80 is going to get included in the next category, which is my 80s. Okay? So then my next category would go from 80 to 90, but not including 90. So we'd include 89.9 here, but not 90. 90 gets included in the next category. 100 gets included in the next. And we're grouping our data this way. All right, and I hope that doesn't cover my biggest bill. I'm going to do one more. So this groups our data into ranges that are 10 wide. Okay, so everything from 70 to 80 goes here, not including 80. So this is all the bills in the 70s, in the 80s dollar, in the 90s, 100s, 110s, 120s, and so on. So the next thing we're going to do is tally it up. It's easy because my data is in increasing order. So there's 3 that fall here, 1, 2, 3. Then we switch into the 80s, and there's 4 of those. Then in the 90s, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That covers the 90s. 1, 2, 3, 4, 5, 6 that fall in the low hundreds here. Then it switches to 110s, 1, 2, 3, 4. Between 120 and 130, there's 2. There's no bills that fall in the 130 range, and then there's 145. So that is our tally column. Tally column is not required. Then we have our frequency column where we just add up our tallies. So the frequency of a $70 bill was 3. The frequency of an $80 bill was 4. The frequency here was 10. 10 families fell in the $90 range. 6 families fell there. 4 here, 2 there, none there, and 1 family had a $140 to $150 supermarket bill for the week. Okay, so this is our frequency table. So how does this help us understand our data? Well, we can see that the most of our families fell between $90 and $100. So this we had up above where the most was called mode. In this case, this is our modal class. It's the most occurring class of data. So the most number of items fell between 90 and 100. So from this data, this class had the most data items at 10 total data items. The second most occurring would have been bills between 100 and 110, and it sort of tapers off from there, and that's pretty standard of data to do that. What else can we pull from this? These should add up to our total number of data points. So let's double check that I did this right. 3 plus 4 is 7, plus 10 is 17, 23, 27, 29, 30. So that's a total of 30, total number of 30 bills that we analyzed. And then we can create a column graph from here. So our data has been grouped. See if I can squeeze this in here. I think I can. I only got to get to 10. So we started at 70. So instead of labeling each class, I'm going to go 70 to 80. And I'm going to count by tens.
Teacher's presence interruption.
So down at the bottom, I'm listing, this is my data supermarket bill. If I had room to label it, I would. So down here, this is our values for supermarket bill. Our vertical axis is going to be our frequency. My frequency needs to get up to 10. That was the most occurring, so let's count by twos. And we can record this data visually. So between 70 and 80, we had 3. Okay, so I went 2, 3. Between 80 and 90, there were 4 bills that fell here. Between 90 and 100, there were 10. Between 100 and 110, we had 6. Between 110 and 120, we had 4. 120 and 130, there were 2. And then we skipped 1, and then there was only 1 out here. This value out here would be considered an outlier. It's separate from the rest of our data. It's off on its own. Okay. And so that would be considered an outlier. So this is our histogram, our frequency table for this data. All right, so this should help you get started working between different ways of representing data using frequency tables and using column graphs or or you can call them column graphs or histograms or bar charts or whatever. Just know that those are all the same thing in this case. Okay, so this gets you started on sections 6A, B, C, and D.